Okay, we have notes about independent and dependent variables. So we've gotten through equations and solving them, and then we've gotten through inequalities. So we're going to kind of, as this is the big idea, we're going to kind of put it together. So the independent variable, we call it the cause, okay? And the dependent is the effect, okay? Cause and effect. So we control the cause. We don't control the effect. Okay? So the dependent variable is changed by the independent variable. Okay? So we don't know what happens with a dependent until we decide what the independent variable is. Okay? And then another way to say equation, I know we've already talked about this, a mathematical statement that two things are equal. It consists of two expressions and one on each side of an equal sign. But I like ours. Remember, an equation is two equivalent expressions. Boom. Okay? So for our key idea, though, we can use tables, graphs, and equations, okay, to analyze the relationship between the independent and dependent variables, okay? So the placement of where the dependent and independent variables go in a graph, table, or equation is always the same, okay? So the dependent variable depends on the independent variable, all right? So example, Jane is making pancakes for her family on Saturday morning. She needs 2 cups of mix for every person she's going to serve, okay? So let S be the number of servings you need to make. Let C be the number of cups of mix you need, okay? So the dependent variable is the cups of mix. Cups of mix. Okay. So C. Okay. The cup of mix depends on the servings, the S servings you need. So what I mean by that is I don't know how many cups of mix I'm going to need to add to my bowl until I know how many servings you need, meaning how many people am I serving? How many people are going to eat? Okay? So, let's go back over here. So she's making pancakes for her family on Saturday morning, okay? She needs 2 cups of mix for each person. So we're going to say each person is 1, okay? And each person gets 2 cups of mix. So my table, we're going to come over here first. We're going to say the number of servings and then the cups of mix. Okay, meaning, let's say only one person is going to be eating pancakes. Well, each person gets 2 cups of mix. So I'm going to have 2 cups. But if I have 2 hungry little bears eating, then I need how many cups? Well, 2 people times 2 cups. So I get 4 cups. But if I have 3 people, well, I multiply by 2, 3 times 2 is 6, okay? That's my table, okay? So over here in my coordinate plane, we're going to graph this, okay? X, so your X, see right here is my X down here, and this is your Y. Your X is your independent variable, okay? We always decide what X is, okay? We control that. The Y is the dependent because just think when we're doing our coordinate plane, you can't plot y if you don't plot x. If you don't know where your x is, you can't put your y. Okay, so you have to know what x is first. So if I have 1 serving right here, how many cups do I need? 2. If I have 2 servings, because this is my x and this is my y. Over 2, I'm going to go up 4. Okay. And then I have 3 people eating. I'm going to need 6 cups of mix. Okay. So my equation is, okay, because remember this is my S and this is my C. So we need 2 cups per serving is going to give us the cups of mix I will end up with. So meaning 2 times 1 equals 2. Okay, another way, there's a table to look at this. Number of servings and then cup of mix. Okay, so 1 serving, I'm going to have 2 cups of mix. 2 servings, I'm going to have 4 cups. 3 servings, I'm going to have 6 cups. Okay, and there's just 3 different ways to do this, and we also have our equation. Okay, so turn it over. So here's another set of notes we're looking at right here. Okay, so we have, after school, you and your friends go to the local gas station to buy chips. Let C be the amount of chips you can buy. Let M be the amount of money you have. Okay? So dependent, okay? So we got to decide, well, what in this scenario, what is the independent variable? What is dependent? Meaning, I can't make a decision without my independent variable. So I have this and this, okay? So, the dependent variable. Well, first of all, you walk in with money. So can you buy 10 bags of chips? Well, the question is, I don't know. How much money will it cost? So the independent variable is the amount of money you have. Okay? That determines the dependent variable, the amount of chips, okay, you can buy. Okay, so look at this. A crew of construction workers can lay 20 cones per minute. Okay, T is the time that has passed. C is the number of cones laid. Okay, write an equation that represents the relationship between time traveled and the distance. Okay, so the independent variable in this example is going to be time. We can't change time. Okay, time is time is time. So I'm going to say this is my independent variable. And my dependent is the number of cones I can lay. Because when the time is up, you got to figure out, well, how many cones? So T is time and C is cones. So 20, they say 20 cones per minute. So 20 times time equals the number of cones. Because if I can do 20 cones per minute, well, when I know how many minutes I've worked, that will tell me how many cones I actually put down. Okay? Let's look at number 3. Manuel saves the same amount of money each month as shown in the table. Determine which statements are true about the amount of money Manuel saves. Okay? So they're saying he saves the same amount of money every month. So month, he saved $15. Okay? So the second month, he has now saved $30 because for 2 months, he has $15 plus another $15, okay? 3 months, I have 15 times 3, which is 45. And at the 4th month, he has saved $60, okay? So let's come over here. The total amount saved is 15 times the number of months. Well, if you were to do the math, 15 times 1 is 15, 15 times 2 is 30, 15 times 3 is 45, 15 times 4 is 60. So that is true, okay? The equation time equals 15 times months represents the relationship between the amount saved and the number of months. So let's see, total saved, T equals 15 times the month. Well, let's try 15 times 1, 15 times 2. So going through, again, that's a true statement. It's kind of the same thing restated. Now, the third, the number of weeks depends on the total amount saved. So what you're saying is this is dependent of this. Is that true? It is not. It is not. Okay. Number 4. In Elsa's first grade class, they are trying to fill up their marble jar. When the class follows directions, the teacher adds 1 marble to the jar. The jar is starting to get too heavy for the students to lift. Okay, so let's look at this. First of all, we'll look at these points. So the number of marbles and then the weight. So again, you have to have marbles before you can have weight. So this is 10 marbles, and after I have 10, it weighs 40 grams. Okay, but when I have 30 marbles, it weighs 120 grams, okay? So it says if 10 marbles are added to the jar, it will weigh 40 grams. Well, is that true? Yeah. And then the weight of the jar depends on the number of marbles in the jar. And yes, because again, another way to know this is looking at your graph. X is independent, and they're saying number of marbles. Y is your dependent. You have to have the number of marbles in the jar before you can get your weight. So that's your dependent. So the weight of the jar, Y, depends on the number of marbles in the jar. Yes, true, true, and true again. Yep, yep. Okay, so that's our notes. You guys are going to practice. We just did them together. You're going to practice this on your own. You can ask questions. You can look at your notes, all the wonderful things. But you're going to practice 1 through 4 here, okay? And practice 2 in the back, okay? I'm going to give you time Friday and some time on Monday to work on these, okay? Yeah. Yep.